In this lesson, we're going to talk about how to graph quadratic equations given the standard form for a quadratic equation. Let's review a few vocabulary before we start graphing. We know that quadratic, the term, means that the equation has a degree of 2. The standard form for a quadratic equation is ax squared plus bx plus c. And the integers represented by a, b, and c are going to be used in the quadratic form. We'll also use them to help us find the axis of symmetry. We're talking about the axis of symmetry. The axis of symmetry is our fold line, and it's where the parabolas are symmetrical. The axis of symmetry also runs through our vertex, which is helpful for us because if we can find the axis of symmetry, it will help us to find the vertex. The equation that we're going to use to find the axis of symmetry is x equals negative b over 2a. So given the standard form of a quadratic equation, we can use the formula here to find our axis of symmetry, which we can then use to find and determine the vertex. When we're graphing, the first thing we're going to do is we're going to find the axis of symmetry so that we can have the x-coordinate for the vertex. When we know the x-coordinate for the vertex, we can plug that back into the equation, substitute it back into the original equation, and get the y-coordinate for it. Once we have the y-coordinate, then we'll have the points for the vertex. We want to determine if the vertex is going to be a maximum or a minimum. So to do that, we need to know if the parabola is going to open up, where we would have a minimum, or open down, where we would have a maximum. And to know if it opens up or down, we look at a. Remember that if a is negative, it opens down, which means that we would have a maximum. And if a is positive, it opens up, which means we would have a minimum. Once we've determined that, then we want to make a table to determine other points that are on the graph. So I would put my vertex in the middle of that table. So in this example, we have our vertex in the middle. And then I would take the 2 points that come before it, the 2 points that come after it, plug those in, substitute those into the equations to get out the y values. And then once you have your points, graph the points and draw the curve of your parabola. Be sure that your parabola is a U shape and not a V, because those are two entirely different functions. So here we have x squared plus 3. Now, we want to determine the axis of symmetry here. Before I do that, remember that I need an A, B, and a C. And right now I'm missing that B term, so I'm actually going to add in the B term by putting in a 0x so that I have that BX term. I can add 0x because it doesn't change the value of my equation. So now I know that A is 1, I know that B is 0, and I know that C is 3. Now remember our formula for the axis of symmetry was negative B over 2A. Well, B was 0, so that would be negative 0, and since 0 can't be negative, I'm just going to write 0. And then 2 times 1, 2A. 0 over 2, which is really 0. So I have x is equal to 0. Now that I know that the axis of symmetry is 0, I also now know the x-coordinate for my vertex. My x-coordinate will be the same as the axis of symmetry, which is 0. Now that I know that that point is 0, if I take my original equation, which was x squared plus 3, and I substitute 0 in, I can figure out what the y value is. So 0 squared is 0, 0 plus 3 is 3, so I know that my vertex is at 0, 3. Is this going to be a maximum or a minimum? Well, because A is positive, my parabola is going to open up, which means that I'm going to have a minimum point. Again, this will be helpful just to make sure that my answer is reasonable. When I finish my answer, my parabola should open up and my vertex should be at the bottom. Now I'm going to make a table of values so that I get some other points here. My vertex is going to go in the middle, and then I'm going to find 2 points that come before, so negative 1 and negative 2. 2 points that come after, that is 1 and 2. And then I'm going to use my equation, my x squared plus 3 equation, and I'm going to put in these points. So my first point is going to be negative 2 squared plus 3. And I'm going to have negative 1 squared plus 3. I already have 0, so then I'm going to drop down to 1 squared plus 3, and 2 squared plus 3. Negative 2 squared, if I go back to this top one, don't want to add another negative on there. The negative 2 squared is 4, and 4 plus 3 is equal to 7. Negative 1 squared is 4, or negative 1 squared is 1, and 1 plus 3 is 4. 1 squared plus 3 is 4. 2 squared is 4 plus 3 is 7. So I have 7, 4, 4, and 7. Now notice these values repeat here, so I don't actually have to put all 4 numbers or all 4 values into the equation. If I do 2, then I can just I just need to make sure that I write the other 2 as the same, so that it's symmetrical. So I have a point at 0, 3. We've got a point at negative 1, 4. We've got a point at 1, 4. We've got a point at 2, 7. And at negative 2, 7. And again, then just draw your U shape. Get your parabola shape as best as possible. Looking at this next example, we have negative x squared minus 4x minus 4. A is negative 1. B is negative 4. C is negative 4. If I'm using my axis of symmetry equation, that's negative b over 2a. Because negative 4, negative b is, since b is already negative, when I put it in, it's actually going to change it to a positive, because the negative of a negative is a positive. So instead of negative 4, we'll have positive 4 over 2, negative 2, because 2 times negative 1 is negative 2, which will give me negative 2. So I know that x is equal to negative 2. My axis of symmetry is x equals negative 2. Now that I know that my axis of symmetry is negative 2, that tells me that my x-coordinate for my vertex is also negative 2. So if I go down and I put it into my equation, my negative x squared equation, so that'd be negative of negative 2 squared minus 4 times negative 2 minus 4. Well, negative 2 squared is 2. Remember, we're going to do exponents before we take care of this negative here. So negative 2 squared is positive 4. And then that negative is going to make that into a negative 4. Negative 4 times negative 2 is positive 8. And then bring down that minus 4. Negative 4, that's negative 8 plus 8 is going to give me 0. So now my vertex is at negative 2, 0. Again, this one's opening down this time because A is negative. So I'm going to have a maximum point here. So I should end up with a parabola that is opening down. I make my table of values. My vertex goes in the middle, so negative 2, 0 goes in the middle. I've got negative 3 and negative 4 that come before, negative 1 and 0 that come after. I don't have to check all 4 of them, so I'm just going to check these last 2 because 0 is going to be an easy number to check. And again, you're putting them into the original equation. So I've got negative 1 squared minus 4 times negative 1 minus 4. And then I've got 0 squared minus 4 times 0 minus 4. Okay, well negative 1, I'm actually going to take that away for a second because I need a little bit more space there. Negative 1 squared is 1. So negative 1 squared is 1. Remember this negative on the outside is going to make it a negative 1. Negative 4 times negative 1 is positive 4. And then minus 4. And positive 4 minus 4 cancel each other out. That leaves me with negative 1. So know that negative 1 is going to be negative 1. And that also means that negative 3 is going to be negative 1. Then I check 0. I've got negative 0 squared minus 4 times 0 minus 4. Well, this is 0. This is also going to be 0. So I've got 0 minus 4. That's going to give me negative 4 and negative 4. Once I have those, then I can graph those points. So I've got a point at negative 2, 0, negative 1, 1, and negative 3, 1. And then I've got negative 4, 4, and I've got 0, 4. And again, then draw your parabola. Again, you want to get as close to a U shape as you can. and then you're good to go. Last example here. So we've got A is equal to 1, B is equal to 2, C is equal to 3. Remember, our axis of symmetry is going to be x equals negative b over 2a. Well, b is 2, so we have negative 2 over 2a, which is 2 times 1. So that's negative 2 over 2, or negative 1. So x equals negative 1. So that means that my vertex is going to be negative 1 and something. So again, I take my original equation, so x squared, so negative 1 squared, plus 2 times negative 1, plus 3. That's going to be 1 minus 2 plus 3. 1 minus 2 is negative 1 plus 3, which is positive 2. And so I get negative 1, 2 as my vertex. Again, this will be a minimum, because this problem is going to open up since a is positive, meaning I'll have a minimum point here. Make our table of values. We've got negative 1, 2 is in the center. This is our vertex. I've got negative 2 and negative 3. We've got 0 and 1. Again, I'm going to use 0 and 1 because the positive values are easier to put in and I'm less likely to make a mistake. And then I'll just transfer this over to negative 2 and negative 3 since they'll be the same. Alright, so I put in 0 squared plus 2 times 0 plus 3. So the zeros plus 0 plus 3, that's just 3. So I've got 0, 3, and negative 2, 3. Make sure I get rid of this so it doesn't look like a negative. Alright, then I'm going to do the same thing for 1, so it's 1 squared plus 2 times 1 plus 3, that's 1 plus 2 plus 3, that's 6. So I've got 1, 6, and negative 3, 6. And then again, I'll graph my points. Again, this should open up. So I've got a point at negative 1, 2. I've got a point at 0, 3, and negative 2, 3, and at 1, 6, and negative 3, 6. And then I get my parabola shape. Again, you want to get that U shape. And this is how we graph a parabola. Okay. Lastly, let's review the steps. The first thing that we're doing here is we are finding the axis of symmetry so that we can use that to find the vertex. Once we have the vertex, we want to determine if it's a minimum or a maximum. Make your table to determine the other points on the graph, and then graph your points. This is how we graph a quadratic equation when it's in standard form.